Hi, Thomas Zachariah. I'm a second-year PhD student at the University of Michigan. I'm going to talk today about what we see as a pervasive closed gateway problem that's hampering the growth of the Internet of Things. And I'd like to discuss a potential solution that leverages the existing mobile infrastructure that's available today. So to start, imagine if every website that you tried to connect to, you were required to install a new web browser or a new Wi-Fi router that had to be created specifically by the site's developer. For example, if you wanted to buy something from Amazon, you would have to install the Amazon browser, and that browser would be running Amazon markup language and Amazon script, and that would be used to display its content. And this would be different from how the Twitter browser would work or the HuffPost browser would work. Similarly, if you wanted to watch a video on YouTube, you would have to go out and buy and install the YouTube router just to be able to stream data from the YouTube servers. Now, this seems absurd, and I'm now a little conscious of how silly it sounds for me to explain this example, but this is actually how a lot of the Internet of Things devices have to connect to the Internet today. In this mad rush to get devices like smart sensors and wearables to market, manufacturers have resorted to making their own application-specific gateways, either as a dedicated hardware router or as a closed software implementation within an app that has to be installed on the phone. Now, this seems ridiculous, especially when we consider how mobile computers connect to the Internet today. We have this really nice model where a Wi-Fi router or a cell tower can act as a universal gateway that sits between the mobile computer and the cloud. So couldn't this work for IoT devices? Well, the issue is that the Internet of Things is beginning to consist more and more of these highly resource-constrained devices. Many of them use small batteries or are just designed to have little impact on energy consumption. This means that communication has to be low power and low cost for these devices. So Wi-Fi and 4G, they're usually just not feasible for this class of device. Instead, these devices use lower powered systems like Bluetooth Low Energy or 802.15.4. And this leads to the use of these closed application layer gateways, which is kind of a huge problem because these gateways leave much to be desired. They are closed off. They provide only siloed connectivity to the Internet. And if every device is required to have its own gateway, it quickly becomes unmanageable chaos, especially when deploying more than just a few devices. We're getting several unnecessary re-implementations of gateways. Like, for example, on that phone, every single one of those apps re-implements a software gateway within the app. And they're all trying to scan, connect to these BLE devices, and send data to the cloud all in the background. And it becomes really inefficient. And then we're also getting into scenarios where smartwatches and fitness trackers can't send data just because they can't access the app on the paired phone that died. And so this just really becomes a huge mess. So it's about time we look for a standard, universal, and open gateway solution. And the sooner the better. So what we propose is a new network architecture that leverages the existing mobile infrastructure and the increasing ubiquity of Bluetooth Low Energy. And this would work by using the smartphones as general purpose gateways that are available for the BLE smart devices. So why smartphone gateways? Well, at the most basic level, they have BLE, they have internet connection, and and admittedly, as application layer gateways have shown, the two can work together. But at a much grander scale, they provide a robust global infrastructure. We have millions of smartphones around the world that provide this vast network of nodes that could potentially provide connectivity to billions or even trillions of IoT devices. And this means that deploying this architecture could require as little as an update to the OS, a software update to the OS. So why are we so focused on Bluetooth Low Energy? I mean, it's a relatively new radio, and the first spec was only just released back in 2010. Well, for one, it's actually already very ubiquitous. Most new smartphones already have it. And because of that, a large number of Internet of Things devices are already being designed to use it. And it's for good reason. It's ultra low power as a well-supported API. And it's low cost. And then another reason it attracts us is because it's literally beaconing us. These devices are constantly advertising what they are and what services they have or want. Just a few minutes ago, performed a scan in this room, and I saw a good 20, 25 devices in this room alone that consisted of Fitbits, Pebble smartwatches, Up 24s, and even beacons somewhere in this room. So today, a lot of BLE devices are used to help the smartphone out. Multitudes of iBeacons like Estimotes and gimbals have been helping smartphones uniquely identify a local environment. And devices like Yuri Beacon provides smartphones with resources for additional information about their environment. So it's time for the phone to return the favor. Any device should be able to reach the cloud through any phone. And with that motivation, our architecture is designed such that these apps that conflate networking and UI eliminate the siloed gateway and allow any nearby phone to collect data for it using a core gateway service. And the user interface would still be able to retain its novelty by continuing to pull data from the cloud. The core gateway service would be central to two modes of operation in the proposed architecture. And these modes of operation facilitate communication between the peripheral, the smartphone, and the cloud. The first mode of operation is a transparent end-to-end scheme that would use the smartphone as an IP router. The second is a middle box scheme that uses the phone as a proxy between the Bluetooth device and the cloud. In the IP routing scheme, end-to-end connectivity is the goal. IPv6 is the way to do this. And IETF and Bluetooth SIG are working on IPv6 over BLE currently. And we're really excited about this, and we plan to incorporate it in our gateway as the implementation solidifies. But at a basic conceptual level, the peripheral would request IP routing, and if the phone has IPv6 network connectivity, it would establish an end-to-end connection, allowing the peripheral to act as any other IP connected device. And the phone would remain as a transparent gateway. Now, the profile proxy would allow connection for the peripheral by letting the gateway act as a middle box. In this scenario, the peripheral doesn't necessarily have to be an IPv6 endpoint, and the phone doesn't necessarily have to have IPv6 network connectivity. So the peripheral would offload the data, and the destination that it wants to send the data to the gateway. And then the phone would repackage the data in a post request and send it off to the cloud. Now, if desired, the server can respond with read and write requests, and the phone will be able to initiate that connection for it. Data can be transported back and forth once this full connection is formed. But this middle box scheme also allows for the addition of some interesting features. For instance, a peripheral could request GPS and time. And if the phone is willing to allow it, then it'll attach GPS, time, and repackage it into a post request, and then send it off to the cloud. So this allows the opportunity to both forward and augment data. And this would be a middle box-like approach. So in order for the scheme to work, our architecture initiates a sort of dialogue between the peripheral and the gateway. The peripheral wants its data to go somewhere, and the gateway is willing and is able and may be willing to facilitate it. The peripheral might want the gateway to provide services like GPS, time, temperature, humidity, accelerometer data that's available on the phone. And it might want to also enable a full BLE connection. And the gateway owner will have the final say on what's allowed. They'll have fine-grained access control. And the gateway owner might require incentive to allow the peripheral to use some of these services, and the peripheral might be willing to compensate for this transmission. So in order to facilitate this, we envision that the peripheral encode a set of parameters to tell the gateway what it wants, which mode, which architecture mode, or where it wants to send data, transport reliability, what incentivization it's providing the gateway owner, and what gateway services it wants to attach. And then the gateway owner specifies what is allowed in his or her access settings. So now this was a very high-level overview of our architecture. If you want to discuss things like implementation at a lower level, I'd suggest you guys come see us during our demo in the evening. But right now I want to mention just a few of several open research questions that we need to answer before our architecture is ready for mainstream adoption. First, what incentive schemes should we be using? Should it be monetary, or can we have a sort of exchanging of services for the ferrying of data, like Google Maps does for traffic data? And how do we make sure all parties involved, the consumers, the manufacturers, service providers, how do we make sure that they're all comfortable with this architecture? Since we're building an open universal architecture, we need to identify some standards. We need to identify the standards to define. And how do we develop a good design intuition on how to actually define that? We believe our architecture will have wide coverage, but sometimes a persistent connection is required. And in these kinds of scenarios, perhaps a static solution, or a static gateway solution is necessary. So can we use our base principles and motivations from this paper to be applied to create a static gateway solution. And in fact, concurrently in our lab, we are working on such a solution ourselves. And then in terms of privacy, how do we maintain the privacy of the gateway owner? And can we identify points of vulnerability and can we fix them? And how do we facilitate a trustworthy relationship between the peripheral gateway and cloud? So, to summarize, today's state-of-the-art internet connection for IoT devices is siloed access. And this leads to the gateway using BLE. And we've identified some key research questions that that we need to address, and I'd love to hear what you all have to say.